The second half of our notes are preparing us for tomorrow's homework, or the next time I see you, homework, which is scientific notation. But all I want to do today is do a quick overview of what our exponent laws are. So here's a list of your exponent laws. These are not in your formula packet. You are required to know what these are and what they imply. So that's pretty important. If you're asked to simplify an expression, kind of like here in a test, which you might be asked to simplify an expression, that means that you just have to know how to do this. That's one of the few things that I will talk to you about this year that you just have to know. So maybe put to the side. You just have to know this. It's not in a formula packet. It's not really going to be guided through. You can't really use your calculator for some of these, right? If you're trying to simplify this, maybe scientific notation, you can absolutely use your calculator. But at any point, if you need to do some sort of manipulation that involves exponents, it's just something you have to know. So the first law is that x raised to the first power is just x. This means that anything raised to the first power is just itself. Smiley face to the first power is still just smiley face. Okay, next law. X to the 0 power is 1. That means anything to the 0 power is just 1. That's for variables and for numbers. Anything raised to the -1 power becomes 1 over that thing. So 3 to the -1 power is 1 over 3. So it'll always be 1 over that. It turns it into a fraction. A tricky thing that can happen is if you have like a fraction, like a half raised to the -1 power. What that does is it becomes 1 over 1/2, and 1 divided by 1/2 is a division of fractions. So if you remember that that's keep 1, change it to a multiplication, and then flip your second fraction. So that's 2. In other words, 2 over 1. So all of this to say that if you have a fraction raised to the -1 power, you actually just need to flip the numerator and the denominator, and it becomes 2 over 1. With any fraction, 3/5 raised to the -1 power is 5/3. And that's it. Okay, when you are multiplying two terms together and they have the same base but different exponents, what you need to do is you need to add those exponents. So x to the 3rd power times x to the 6th power. They have the same base, which means I just need to add the exponents, and it becomes x to the 9th power. In the opposite, if you have the same base and you are dividing these same base terms, then you take those exponents and you subtract them. So if I were to do x to the 6th divided by x to the 3rd, that would be x to the 6 minus 3, which is x to the 3rd power. However, when you are raising an exponent to another exponent, that is when you multiply them. So x to the 3rd power raised to the 6th power is going to be x to the 3 times 6, which is x to the 18th power. When you have two terms being multiplied together inside of a parentheses, you distribute that exponent to both of the pieces, x to the n and y to the n, which makes sense. The number one way I see people mess it up is when we do something like this. 2x in parentheses to the 3rd power means that you need to distribute that cubed piece to both the 2 and to the x. The number one mistake I see students make. 2 cubed, x cubed. All right. Similarly, if you're dividing something and you're raising it all to a certain power, you need to apply that power to both of the terms. So 2 divided by x raised to the 3rd power is going to be 2 to the 3rd power over x to the 3rd power. Or if it was x over 2 to the 3rd power, you need to make sure to distribute that 3rd power to both of them. This guy and this guy are coming from the same family of an idea of when you have a negative exponent, you flip the fraction. You can think of this as x over 1 raised to the -1 power. So really what you've done is just flip the fraction. Now this is when it's not -1. You just have to then take that exponent and make it positive in the denominator. So x to the -5th power is 1 over, and then x to now the +5th power. That rule is happening up here. This becomes 1 over 3 now to the +1st power. This becomes 2 over 1 now raised to the +1st power. But since it's just the first power, it's just that thing, and so we just make the 1 go away. Here is saying, well, technically, if it's something else besides 1, you're going to keep that exponent at a positive. So again, like 3 to the -4th power is 1 over 3 to the 4th power. If it was a fraction raised to a negative integer, you would flip the fraction and now turn your exponent to be positive. Okay, let's practice. We want to combine all of these together as much as we can. So that means that we've got to look at the bases. And notice that all of these guys are 2. There's a base of 2, so it's pretty consistent. The addition here is really tricky because notice that there's no addition on the left-hand side here. So there's no way to combine these 2 separate terms. It still has to stay as an addition, but we're going to look at each of these terms individually and see what we can combine. So 2 to the 1st power divided by 2 to the 3rd power. If you have the same base and you're dividing, you need to subtract those exponents. So I'm going to do 2 to the 1 minus 3 plus. If you're raising a power to another power, you need to multiply. So that becomes 2 times 3. So 1 minus 3 is -2, so that becomes 2 to the -2 plus 2 times 3 is 6. I cannot combine these because you cannot add these guys together. You can only combine them together if you're multiplying them or dividing them. It does say that we want them in positive powers. So since I have a negative power here, I need to turn it into a positive power. The only way to do that is if I turn it into 1 over 2 to the 2nd power plus 2 to the 6th power. So now I've combined all terms as much as I possibly can and turned all of my negative exponents into positive exponents. And I have completed as much as I can. All right, next one. We've got 4 to the 3rd power times 4 to the -7 power. Since these guys are being multiplied, what I do with these exponents is I add them. So I'm going to do 4 to the 3rd plus -7 divided by 4 squared. Adding a negative number makes it a subtraction, so then that becomes 4 to the -4 over 4 squared. Dividing with exponents, same base, you need to subtract these exponents, so that becomes 4 to the -4 minus 2, subtracting that 2 from the -4, so that becomes 4 to the -6. Again, we still need it to be positive, so I'm going to turn that into 1 over 4 to the 6th power. Okay. Now we're going to do this without having our numbers available to us. We're only going to be using variables. So we've got 1 over x squared raised to the 4th power. So I'm going to apply that 4th power to the 1 and to the x squared on the denominator. So it's become 1 to the 4th over x squared raised to the 4th power. 1 to the 4th power is just 1. When I'm raising an exponent to another exponent, I need to multiply. And you're done. It doesn't say positive, just a single power of x. So that's fine. You could also write it as x to the -8, which is why I was hesitating before. Those would both be acceptable. All right, we've got x cubed times x to the -1. I know I need to add those guys, so that becomes x cubed plus -1 divided by x to the 5th. So that becomes 3 minus 1, so x squared divided by x to the 5th. We want these all to combine together, which means I need to combine using this division right here. The division means that our exponents are going to subtract, so that becomes x to the 2 minus 5. Which is going to be x to the -3. You can keep it like that, or you can do 1 over x cubed. Those would both be acceptable. And that's all you're required to know for these notes for this lesson.